almost?
Yeah, almost.
Okay, so first, we know by definition the square root of negative 1 is I. We know I to the 0 is 1, I to the first is I to the second is a negative 1, and I to the third is a negative I. And you probably did this back in Algebra 2 and at the first of this year when you did college algebra, but could you figure out what I to the fourth is? You don't have to write this down, this is just to see what you remember.
I would be -1.
It is 1. Because wouldn't it be I squared times I squared? And I squared is a negative 1 times negative 1. You guys get that? What would be I to the fifth?
-1.
No.
Negative I, wouldn't it?
I to the fifth, couldn't that be I cubed times I squared?
Yeah.
And we know I squared is a negative 1.
I.
We know that's a negative I, so we get I. What's I to the sixth?
-1.
I to the fourth times I squared.
So it'd be -1.
So that's 1 times negative 1, so isn't it a negative 1?
Yeah.
This part you don't need to write down, we're just kind of reviewing. Hopefully you did this earlier.
Isn't there a pattern?
That's what I wanted to hear. What do we know I to the seventh is? I to the fourth times I to the third? So I to the fourth is 1, and that would be a negative I.
So it goes 1, I, negative 1, negative I. 1,
Kind of like Mississippi, crooked letter, humpback, humpback, you know, that same principle?
Yeah.
So it goes 1, I, negative 1, negative I. So if I ask you what I to the eighth is, what would your answer be?
1,
About I to the ninth?
I,
I to the 10th?
-1.
I to the 11th?
Negative I.
So it's A, B, negative A, negative B.
What if I said now, what's I to the 33rd power?
No say.
It just looks like those four.
What's the pattern? Takes 4 to recur, right?
Yeah.
Mhm.
4, 5, 6.
So if I were to take 33 divided by 4,
So then it would be.
remainder 1, the remainder is what you need. So what's I to the first? I. See, like down here, didn't you know what I to the 11th was?
Yeah.
Okay, if I took 11 divided by 4, my remainder is 3, so this is the same as I cubed, which is negative I.
Oh, what? Okay.
You guys follow what I did? Let's try a larger one.
I guessed so.
107.
I got it.
100 and, is that in your assignment?
No.
No, okay.
I just like that number.
107. So first I would divide by 4 because it cycles every fourth one, so that's why it works. So that would go in there, what,
26. Remainder of 3.
26 is the remainder of 3.
Yeah.
So that means I to the 107 is I cubed, which is
Negative I.
negative I. Which,
But-
imaginary numbers, you will never have a power on them if you've done things correctly. Because I cubed, I to the fifth, they all go away. Largest power you'd have is to the first.
Because it cycles every 4.
Every fourth one. So that's why we divide by 4. What if I had I to the 52nd?
You take 52 divided by 4.
That
comes out evenly.
Remainder,
0.
so 52 is I to the 0, which is 1.
Ah!
So do you guys see how to simplify that?
Yeah.
Okay.
Just 1 second.
So remember, it cycles every fourth one, that's why we divide by 4. The remainder ends up being your answer. Okay? So this is why you only needed these, because it cycles. That's the reason you only need these 4.
The cycle is
Why does he need negative?
Every fourth one, and if you divide, the remainder is your answer, whatever the power of the remainder is. Okay, so in addition to that, you should have already simplified radicals that have negatives underneath it. So if I were to have, and just need to write down a few of these. What if I have a negative 18? How can I simplify that? Isn't that the same as a negative 1 times 9 times 2? We know the square root of a negative 1 is I. That's by definition. What's the square root of 9?
3.
And we don't know the square root of 2.
Oh, I thought it was 9.2. Okay.
Okay? What if I have square root of a negative 56?
2 and.
We know it's the negative 1 first.
Okay, yeah.
I think 4 goes to
7 and
56. Yeah, but 7 and 8, neither one are perfect. I think 4 is goes into 56, doesn't it? 14 times?
14, yeah.
So you'd go 4 times 14. The square root of a negative 1 is I. The square root of 4 is,
2.
but you don't know the square root of 14.
I like this.
Okay, what if I have a negative 100?
Negative 1.
Times 10
25.
times 10.
What about 100? Isn't 100 a perfect square?
Just,
Yeah.
yeah, it's just 10.
So the square root of a negative 1 is I, and the square root of 100 is 10. And you guys remember simplifying with negative numbers? Yes?
Yeah.
Okay, so we should be able to simplify. We should be able to simplify a power, I to any power. And now we're ready for operations. Addition. To add imaginary numbers, which an imaginary number, a complex number we call a plus bi, I always say line them up. You got 3 plus 5i, and you're going to add 6 minus 7i to it. So you line up the like terms. What will you get when you add them? That's 6 minus 7i.
Negative 3.
Now what's 3 plus 6?
9.
And that would be your answer. Okay, what if I have 8 plus 3i square roots of 2 plus a negative 6 minus 2i square roots of 2? Again, line them up.
Same thing for subtracting
plus-
them.
I squared to
Yeah, we haven't done subtraction yet, but we'll look at what we do.
2 plus I squared.
So that's 2, and this goes to 1, doesn't it?
What
Plus
if,
1i radical 2?
if they aren't common, like if one is square root of 2 and one is square
You have to write them both down.
Okay, so it'd be like 2 plus I squared.
Like if this was a 3, I would say 2 plus 3i radical 3 minus 2i radical 2. You just have to write them both down.
Okay.
Okay?
I gotcha.
Subtraction. 5 plus 3i, subtract 2 minus 5i.
I can't. Okay.
You do the same thing, you line, write down the first one, but you change the sign.
3 plus 8i.
So you just plus.
Wait, no.
So this is subtract, so I change the signs of everything that's being subtracted. The 2 becomes a negative, the 5i becomes a positive. Now combining like terms,
3 plus 8i.
okay, so I write down the first one, 8 minus 2i. And I'm subtracting, so what do? Change the signs of all of them.
Plus 5 plus 6i.
Now what would I get?
13 plus 4i.
Now, you've got this written down. This next one you don't need to write down, but it's gonna be,
Do we need to write down the simplified thing, or? If we
no, you should have known that one,
Okay,
I would say. That was just kind of a review thing.
right.
Okay, what if I have 6 plus 5i minus 3 minus 2i plus 8 plus 4i? This is a combination.
Would you distribute the negative and then one the
Now I would just write down the first one as it is.
Is that
I'm
two?
subtracting, so it means you're gonna change their signs.
Okay.
And I'm adding that one, so it's gonna be just as it is, right?
So it'll be 11 plus 11.
What do I get?
Wait, no, not 11, but 14 plus 4.
What?
Yeah, 11
She's
plus
just
11.
learning the math.
Yeah.
That's the first time.
So this first one is 6 plus 5i. The second one you're subtracting, so you change both their signs. The third one you're adding, so you just lined it up. And now you combine like terms, and it's 11 plus 11i.
Yep.
Okay, multiplication. Write this one down.
Oil.
Oil. So let's start. Richard, what's first times first?
That's 15.
Taylor, what's the outer?
12
Negative. Okay. Becky, what's the inner?
Ta-da.
And Tara, what's last times last?
Negative 8i squared.
Now, we need to use that little table that we have. I to the 0, I to the first, what's I squared change to?
-1.
So this is a -1, so what's a -8 times a -1? Positive 8. So I have 15 minus 12i plus 10i plus 8. Combining like terms,
7.
I've got no, 15 plus 8
23.
becomes 23. What's a -12i plus
Wait
10i?
one second, what did you do after we found out?
Right here. I squared's a -1. A -1 times a -8 would be a positive 8.
Okay.
Then you add your like terms, so 15 plus 8
minus 2i.
minus 2i. What if I have 6 plus 2i quantity squared? What was that, what does that mean?
They're multiplying it by itself.
So you write it down twice, right? Quantity squared means you take it times itself. And we're ready for, oh, we'll just start with Dalton. What's first times first?
36.
Mason, what's the outer?
12i.
What's the inner, Delaney? Yes.
Oh, what?
Delaney D, what's last times last?
That is 4x squared.
Now, what can we simplify, Zach? What's I squared change to?
-I, -1,
So what's 4 times a -1?
-4.
So that ends up being a -4 then? Combining like terms, what's 36 subtract 4?
32.
And what's 12i plus 12i?
24.
Does it matter if we write the I one first or the?
Well, you should, the form of a complex number is called a plus bi.
Okay.
So you write your I term last.
Last.
One more here.
I have a question.
Yes, sir, Richard.
Would you be able to divide that one by 4?
You can factor out a 4, but you don't need to.
Okay, I just wanted to ask.
You can factor out a 8 too, but
What
Okay.
would you do after the? Okay, so whenever it was just 6 plus 2i squared, is that just the problem that it gave us? Or did we just?
it's 6 plus 2i squared, which means you take it times itself.
Okay.
Right.
Gotcha.
Okay, this one, using FOIL, let's see. Taylor, what would be first times first?
9.
Mhm. Richard, what's the outer?
-59.
Becky, what's the inner?
15.
And what's last times last, Tara?
-25 I squared,
And what's I squared changed to?
-1.
So a -25 times a -1 becomes a positive 25.
E.
So what's 9 plus 25? And what about my eyes?
They
Cancel.
cancel.
So that's it.
Which, did you notice anything about the original problem?
They had all.
It was a difference with squares.
They're exactly the same except one's positive, one negative. Those are called conjugates. And anytime you have conjugates, all you have to do is take first times first and last times last. You don't have to do the inner and outer because they always cancel.
Sweet.
So all you had to really do is go 9 minus 25i squared, and then it simplifies to a nice real number because the I squared changes to a -1. So let's look at another one. Let's go with 2 plus 4i times 2 minus 4i. First times first,
4.
4.
last times last.
-16i squared.
Okay, because they were conjugates. Now, I squared changes to a -1, so a negative times a negative is a,
Positive 16.
1.
4 plus 16.
so our answer is 20. Okay, so we've done addition, subtraction, multiplication, simplification. One last thing. 5 divided by 1 plus 2i.
And
What do we do?
1 plus
Multiply
2.
the top and the bottom
By the conjugate,
by the conjugate.
So 1 minus 2i.
right?
Hold on. And why do we do that again?
Because you can never have a radical in the denominator, and isn't the I technically the square root of a -1?
Yep.
And that's why you multiply by the conjugate, again, because that gets rid of it. So on top, it's an easy fix, isn't it?
Yeah.
It'd be 5 minus 10i on the bottom, it's a conjugate, so all you gotta do is first times first. So it'd be 1 minus 4i squared.
Yep.
And 4i squared, the I squared changes to a negative 1. So it makes that a positive 4. And now, can I divide each of them by 5
Yep.
to simplify? So 5 divided by 5, and 10 divided by 5.
It's just negative 2i.
Was that 1
1
plus
minus
4?
2i. Mhm.
But
Minus 2i.
when they marry.
Yes, that's why I divided everything.
Oh.
See, if I factored out the 5, it'd be back to everything. As long as you divide everything by the
Okay.
same thing, you're okay.
This is
So
not
the answer's
divorce.
Yeah, it's like separating a whole thing. It's like a poly relationship.
Okay,
It's like a poly relationship.
okay, let's go. Taylor, what would I multiply by? And then we'll go down the row with you guys helping me again.
2 plus
What-
4i.
2 plus 4i. Richard, you're gonna get the easy part. You get to multiply the denominator. So that's first times first and last times last, because they're conjugates.
4 minus 16i squared.
And what's that become?
That equals 20.
Good. Okay, on the top, Becky, first times first.
4.
Kara, the outer.
Can I catch up?
Yep.
Sorry, I'm trying to. Okay, now what's the question?
Yours is the outer.
Okay, 8i.
Right. Okay, Dalton, you got the inner.
6i and plus 12i squared.
Okay, now, Mason, how can I simplify?
Oh, let's see.
I squared changes to,
The negative 1,
so that makes that a,
negative 12,
okay? So what's a negative 12 and 4?
negative 8,
What's 8i plus 6i?
49.
That doesn't look good.
You divide all that
Now, Dalton just said we could divide everything by 2, so Delaney, yes, what could you get if you divide the 8 by 2?
Negative 4i.
And the 14?
7.
And the 20.
10.
So we end up with negative 4 plus 7i all over 10. And now, I like it left that way, although when we do competition at Math League, which you guys used to, they make it where you have to write it in the form
Oh, that's terrible.
a plus bi form.
Why?
Because they want it separate. You know, I said a complex number is a plus bi,
Yeah.
which all that is you just put them both over the same
I
denominator.
don't
Yeah.
do math league anymore.
You guys went to the block for a while, which took away time from your class.
We're too smart to win.
You probably would.
Oh, really?
Okay. 5 minus 3i over 2i. I'm gonna try one more. Delaney,
I'm ready.
Davis, what would you multiply by?
I
What's the
multiplied
conjugate?
both of them by negative 2i,
Good.
Wait, there's an there's
and I would get negative 10i plus 6i squared all over negative 4i squared. I'm done.
We did all the multiplication. Let's see if Zach can simplify then.
Yeah.
For your denominator, that I squared will be a negative 1, so that'll just turn out to be a 4.
Good.
And the top one will also turn into a negative 1, which will turn into negative 10i minus 6.
Okay, then everybody, can you reduce it?
Yes.
Let's do.
1, 3.
So you get negative 5i minus 3 over 2.
Yeah.
And if you prefer it, you can write it in
Negative 5
Wow.
over 2.
a plus bi form.
Negative 4 over 2 plus negative.
Wait, are we
Can't you
supposed
just-
to put the I term at the back?
Notice I did that when I wrote it in a plus bi form.
Okay.
So the first one would have been 4 over 10, so like 7, yes.
Oh, I should have had a 4 there. Why didn't I write there? You guys didn't catch it?
No.
Yeah,
Is
I
it
thought
wrong?
maybe there was a reason,
Is
and I
it-
was just going crazy.
Is it wrong if we write the I first?
No, I'm not gonna count. Why not? Tell me what property allows you to have things in different order. You can tell me that, you can do
Is
it.
it communicative?
You got it.
Oh, okay.
Yeah.
I knew.
A plus B is the same as B plus A.
I failed
Okay,
that.
now, let's look at page 583.
Oh, but. That's not very close to the one, right?
a mixture of simplification from the beginning. Do you guys see on number 13, it says I to the 6th?
Give me one sec.
Yes.
So we know what to change that to. Remember, it cycles every 4, so you divide by 4 and the remainder is your answer. So I see number 15 says 1776.
Let's do that one together.
Then I think you can divide by 4.
Oh, man.
Oh.
Okay, then you've got addition, you've got subtraction, you've got multiplication, more multiplication, and then division on 25, 26, and 27. And then problem 30, what are you doing there?
Distributing twice.
You're multiplying twice. So this you don't need to write down. If I have 5 plus 6i times 2 minus I times 3 plus 2i.
We do want to FOIL the first two.
Okay, FOIL the first two. So Delaney, go ahead. What do you get there?
10 minus 5i plus 12i minus 6i squared.
Okay, and then Zach, you simplify. You do a good job there. So the I squared changes to,
-1,
so makes that.
+6,
So if you add it to the 10 gives me,
16.
and a -5i plus 12i is,
That is 7i.
now we take it times the last one, and what would I have to do to get the answer for it? FOIL again. So I only gave you one of these. So that ends up being, Dalton, we're ready for you. What's first times first?
What? 48.
Outer Mason,
I can't.
16 times 2.
16 times, 32.
Delaney, 7i times 3. Enter.
21i.
And last times last, Becky.
14i squared.
Multiply that again.
Oh, that's how I was looking at the 7.
Oh, you're right. I'm not looking at the right one.
You have 2i, which should be 21.
Oh, they said 21, didn't they? Thank you. I just didn't write it. Now, Tara, what can you do?
You can change the I squared to -1, which would change the 14 to a -14. And you can combine those, which give you a number.
And that number is?
34.
34.
And then 32 plus 21 is 50.
Those are numbers.
Okay.
Like I predicted.
So, 13 through 27 and number 30. Do you guys have questions?
No.
I don't think so. What did we do, like, how did you do yesterday?
What?
I would say yesterday was Thursday.
You mean last Thursday?
Yes, the
You could watch the video at this point.